Alright, so in this video we're going to talk about some servo controls, and what we're going to do is that we're going to actually show you how to build everything from scratch. So basically it's going to be a very detailed video. I'm going to show you everything you need to know as far as the fundamentals of getting started with servos and getting started with using that in RSLogix 5000 or with Studio 5000. Now again, this will not be a very fast-paced video, although it will be a video where we're going to do some things rather quickly that do not really kind of correspond with servos. So with that said, I've already kind of built a program, just started it, basically opened it up and gave it a name called Servo 2020-23, right? And then what we're going to do is we're going to first change our main task, right? So I'm a big advocate of any kind of servo controls. I automatically will change the task from continuous to periodic, because I feel that, especially with servos, the number one thing that helps us is timing. So I'm just going to put it at 47 milliseconds, and to help us out, I like to go ahead and name it 47 milliseconds on the outside of the for the name of the main task, so that it actually gives us the understanding that it is 47 milliseconds, even though depending upon which version you're running, it's going to highlight that on the outside and the quotation marks like you see. Now I am currently using version Studio 5000 version 34. Now, with this said, all this that I'm teaching will correspond with the same thing with RSLogix back down to version 19.8. Well, all the way back down to just about version 16, all the way to version 34, like you're seeing now. So when it comes down to it, I want to break down and show you the base principles behind this. So first and foremost, I'm going to make this really simple on myself, and I'm going to go ahead and download this program, and I'm going to go ahead and add all of my components, meaning I'm going to go ahead and add my my trainer. I have an actual trainer sitting right beside me. As you can, I have the actual camera pointed to the servo motor right now, and the actual controller right here. So this is going to be a Kinetic 6000. Okay, so and contrary, I know there's a lot of people that use Kinetics, the Ethernet version and stuff of that nature, but this is going to be a Kinetic 6000 with Sercos. And just because that's what I've had for years, that's what I'm building up things on. And actually, when it comes to programming, there's a lot of things that are still Sercos in this industry today. So what we're going to do is we're going to download our program right now, so that I can easily go ahead and use the discovery module or discovery feature to discover all my modules inside of my trainer. Now I would show you my trainer, but moving around, as you can see, you can probably see up top, you can kind of see all the rack, you can kind of see the PLC processor and everything. There's buttons and everything behind that as well. But let's go ahead, now that we're online with it, let's go ahead and discover our modules. And I'm going to make this real quick and simple. So we're going to go ahead and add our Ethernet module, and we're going to simply just call this Ethernet. Okay, and then we're going to go ahead and add that. And then the next module is going to be our digital input. Real simple, real easy. Let's go ahead and we're going to copy that, and we're going to do that same thing on the digital output. We have a digital output right here. I'm just going to paste that in there and just change the last few words to output. Okay, so that way we have that nice and quick and easy. I told you this would be very simple. And this is going ahead and adding our analog card, which is analog IO, because it's in and out, right? And the version of the analog card I have is in and out. So with that said, we have all of our stuff added right now for our actual, except for our Sercos. We didn't add our Sercos module, which we can come in here and we can see the Sercos module right here. Now, the one thing that I will highlight here is, okay, so you notice I'm running, if you open up properties and my controller properties, I'm running version 34. Okay, so with Sercos, with your communications, you need to be set up to running the Sercos module that you need or that you're using has to be flashed to the same exact version of the PLC processor version, right? So the same firmware. So we'll go ahead and add that module, and I'm surprised it didn't show up under Discovery, to be honest with you, but it did not. So we're not going to sit here and actually it's right here. This module can't be added like that. Created, go to create offline. So let's go ahead and go offline right here, and let's add that in here. So we'll create that module, and there's no discovery again when it comes to that. So what we're going to do is we're going to go ahead and then we can go to favorites. Let's go to filter, and we'll say motion. Let's see, let's see, this would be a Sercos. Okay, so this is going to be a 1756 M16 SE. That's the version that I have. That's the actual, so it, meaning this card can take up to 16 axes. In this case, it's going to just basically be doing one. I do have a physical axis. This is going to be in slot 1. So we can go ahead and add that in there, and currently you can look at your interfaces. The data rate you generally want to keep at auto detect. Your cycle rate, that depends on your cycles. I mean, how fast do you want your Sercos to work? I always keep my system on high power, and then I transition to phase 4. Transition into phase 4 is obviously giving you the happy state. Now you see this is in version, or is in 2 right now, because it does not know who it's owned by and nothing like that. So right now this is going to hit apply, and then from that we'll go ahead and add our module. So adding in our module, and we're going to come in here and add in our module right here. So we'll go into the Sercos network, hit add module, and what we're going to do is we're going to add our module, and we're going to use this based upon our number down here, and this is going to be a 2094. So 2094, and it's a BC01 M01. So this is the M01 right here is, if you can think about it, this is going to be what they call an IAM, which is basically your power module. So not all servo controls, like the BM down here, is just a standard plug-in, which would plug in the second slot over here. So this empty slot right here, this is actually the power module, and it can be used and is always used as a servo as well. So it's not just a power module, it's a power converter, which I'm currently running this off a 110 system, and I have all of my system. I went into the configuration of this module and put it in demo mode so that I can actually utilize a standard 480 control to my servo motor and actually do that through basically the duration inside of this module. So that's not often going to be done in the industry, so I just wanted to highlight that. But I am running this, this is my 2094-BC01 M01, and that's going to be the module I'm using. Now I'm going to name this, and we'll name this trainer servo controller. Okay, and the node on it, currently the node is dialed in right here. There's a Sercos node that you can change right here. I have mine set to 10, so I'm just going to up this to 10 so that it does communicate. And that way you already know that. Now, so we do not currently have any axes inside of here yet, but we do have our Sercos network set up, and we do have the communication set up to our actual our actual Kinetics 6000 drive. Now, so we're not going to worry about any of these other properties right now, as far as like connections and our associated axes, because we don't have any associated axes. What we're going to do now is we can come in and add our axis, but first we need to add in a motion group. So up here in motion groups, one thing I want to highlight before we get into motion groups is I want you to go into the properties of your PLC processor, and you want to go into the properties right here and go into date and time. Now, date and time, I want you to turn on what's called time synchronization. Now, if this servo is being controlled from this processor, then time synchronization needs to be turned on. However, if this servo is not being controlled from this very PLC processor, then it does not need to have the enable time synchronization. Now, I'm going to show you how to, my system currently is the example that I'm showing does actually control this very servo. So my PLC will control this servo through this Kinetics drive. So I do have to have enable time synchronization for this to work. What that does is it relates time with the actual servo and its actual data that it gets, right? So that's one common thing that you need to know, and a very helpful tip that a lot of people forget about and they don't add. So we're going to come into our motion groups, and we're going to add a new motion group. Now, what this does is you can name this just about anything you want to. So I'm going to name it trainer. We'll call it trainer motion group. So you can name this anything you want to. All it is basically a motion group name. You are going to be using this tag throughout the program, but I will say that this is just giving you where you add all your axes from here. Now, again, when it comes down to it, you can add a servo drive, a consume servo, or axis consumed, axis servo drive, an axis general drive, SIP motion, basically, and a virtual axis. So virtual axis, again, is basically something that you would utilize that's not physical. It's not going to be any kind of tied to any physical device whatsoever. So in our case, we're going to do a servo axis. Actually, let's go, I believe, let's try servo drive. Well, let's do servo axis for this one. Servo axis, and we'll call this trainer servo. Alright, so this is going to be create that. And this is going to go ahead and allow me to go ahead and add in everything that I need to add in. So now this is going to be automatically tied into my motion group. Now there's two things here I want you to understand. When it comes to servo, or when it comes to where you're tying it into the Sercos card where the controller is, right? There's a couple different things. So you can come down here to open up here and then go to associated axes and select that if you want to. Now again, this axis right here is not actually shown like that way. So when it comes onto it, when you see this is a coming in showing that. So let's just go ahead and add in our motor for that aspect. Actually, this is a servo. We need to add in a servo drive. So let's actually delete that and come over here and add in a servo drive. And again, call this trainer servo. So I wanted to kind of show you that because again, it does differ a little bit how you're trying to use it. See how the everything changed. Now I have the first. All right, so to clarify this real quick, if you were to add in a servo, this would be like something that is external, like you wanted to incorporate a encoder or something of that nature and use it as a servo, or something that is referencing something like that. Maybe it could be a linear transducer or something that you wanted to actually utilize and consume in your program. The servo drive is going to be what's linked to your actual down, all the physical attributes or physical properties down here. So as you see, the properties in here are completely different now. So you can see now it says associated module. I can choose my trainer right here. So I want you to see this real quick. So down here, I can open this up and change to my associated modules to my actual trainer servo. Now you can do that there, or you can do that up here. Either one is just the same, so I like to actually do it up here. And then once you do it up here, you'll come down here and you'll see that it is automatically tied into that. So it does work either way, so you could do both ways if you wanted to, depending upon what you chose to do. Now, in my case, I'm going to actually, pull up my motor that I'm currently running and kind of show you that, right? So I'm actually running a motor. Let's change this. This is the amplifier. So this is where you come in and put your catalog number or your motor catalog number, and you get that directly off the motor nameplate. Now change that to what you're currently using. Now I'm using a MPL. I'm using an MPL, and let's scroll down right here. I'm using MPL B310P. So go down here, B310P, and I'm using an M. So and the reason I'm using an M because I'm running a multi-turn encoder. So that is the exact reason why I have that. Now the attributes, the drive resolution, I should say, I'm going to leave at how it's currently there, but you can come in here and calculate that if you wanted to. Let's get into that a little bit in a different time. Now coming down here to real world access information, generally speaking, I like to get something like let's just say torque feedback, and then like a position error or something like that. Those are the two common things, and then hit apply. Alright, so with this said, now our feedback is automatically done for us because we selected that based upon the motor. So as soon as we select our motor, it basically fills in a lot of this stuff for us. Now the conversions I'm going to leave as default because we can have probably another 2-hour video talking about how to set conversions on a servo motor. Now when it comes down to it, homing is another I guess important process when it comes to servos. So understanding that you can change your homing method to active, passive, or absolute. Absolute means that basically that's going to be whatever position you deem it to be, and then you can come down here and that would be, you would have to trigger that. Now passive, active, you would come down here and you can change to a switch, which you can actually have it home to a proc switch or to a photo eye or whatever the case may be. A marker, switch marker, you can do torque level, so you can actually have it home to a certain torque level if you wanted to. I'm currently not going to do that. I'm going to do an immediate, but just know that you can change all that down here. When you're probably going to ask yourself, what is a marker? I'm going to explain that to you in just a second. So we're going to come in here and actually hit apply for all this, and if we did everything we were supposed to do correctly, now if we go in and download this to our actual PLC program, right, like we did earlier, we're going to download this. Everything should come up and be happy, meaning all of the stuff in our IO tree should be happy. The Sercos, or the actual Sercos ring, should go from a 2 to it should go to a 0, 1, 2, 3, 4. Okay, so if everything's set up right, we should see all that. And let's see if we have everything set up right. So currently we have is going to a 1. So it's checking a 1 right now. It's checking a 2. It's checking a 3. And then it's going to a 4. So we do have everything set up properly. So what I do highly recommend is you be a little bit patient with it. It shouldn't take very long, but it should take a little, it might not be as quick as you expect it to be. So just be patient with it and make sure that your Sercos ring does go to a value of 4. That's a healthy system. That means basically 1 through 3, like I believe 2 is checking the module, is checking the actual drive. 2 or 3 is actually checking that the drive and the servo are attached, and that the actual servo motor itself is actually installed properly, meaning it does actually have, if you go into properties, you did select the proper motor that it is being used, meaning it does look at the encoder and make sure the encoder is actually what it's supposed to be. Alright, with that said, we can come over here and go into our program. And what I like to do too is, especially on a new processor, is I'll go in and select match the date and time to the actual workstation that I'm using. But if you notice, and you should have right here, you notice if I go in date and time, you can see that my time synchronization is on. So this is the system time master. So that means this is the system time master for the actual servo. Now when it comes to servos and it comes to actually running them, I'll actually show you real quick. You can come over here now that we have everything working. Our IO is completely healthy, and everything is working. I want to talk about the over here on the motion group, the attributes. Okay, so it's very important that you understand, and if you're using an L6 processor, timing of the course rate update, which is the base update time, is very important. Alright, so this has to be set properly. You can see your max times down here, but if you're using an L7 or an L8 processor, especially an L8 processor actually has a quad core system, so there is a sector of that processor that is dedicated for servo controls. So it is a lot faster. In my case, I only have one servo, so 1 second or 2 milliseconds is completely fine. But just know that your anything that you actually write in the program, or the PLC program itself, has to, like, your maximum update rate is going to be, or your update rate for getting any information from the servo is going to be 2 milliseconds. Okay, so if you wanted that lower, you can get it lower. I can come over here and get that a little bit lower. If I go offline, I can change that right here and change the attribute. I can change that to 1, and change alternates. But again, when it comes onto it, you can schedule axes and schedule different things in here. I don't necessarily, again, have anything in here, so this is not necessarily something I'm going to do. I'm going to set these as they should be, just like I just did. I set them out here, but you can use this schedule axis schedule if you choose to. Just know that if you have multiple servos, generally a servo that is connected to a real-world servo or real-world controller like this one is, it's going to be counted as a 0.5. It's going to add, every one that you add is going to be a 0.5 milliseconds. Now if you add in like a virtual axis, it does add up to 2 milliseconds, because they do tend to increase the milliseconds or the data that's being consumed, because it is virtual and it is actually being used off the PLC processor that you currently have. So in this case, it would be the L73 processor. Now, what I want to highlight here too is this is all dependent upon what processor you're using. If you're using an L6, the scan rate is a lot slower. L7 scan rate is a lot faster, and an L8 is far superior to both the L6 and L7 processors. This is using, again, the RSLogix chassis. So with that said, we can actually get some motion in here if we want to come over here and do, and let's go ahead, since we changed our motion, we need to come over here and download again, since we actually changed the motion group update rate. So we're going to download to that again. So make sure you understand that when you're doing that, if you're changing something of that nature or anything to do with a servo, you're going to have to do that offline. And let's see, it failed. Let's see, I wonder why it failed. Let's see. Let's look at I can see the results probably, but let's see if there was a problem. Let's see, it canceled the trainer update course rate multiplier. So it does actually require me to be at a value of 2 as default, and that's probably because it's my lead. So let's go to 2, let's come back here, go over here, come back, and then download again. So just keep that in mind. I was just kind of basing a point behind that, but again, when it comes onto it, I did forget that the lead of this actual servo is going to be, this is the IAM, which is the power supply. That very one needs to be 2. Alright, so with that said, we're going through checking our Sercos again, 1, 2, 3, 4, and you can see that down here there's an error code, but again, all it's doing is be patient. It's checking itself to make sure that the values that you did put in are correct. Alright, so now that we have this, let's go ahead and show you how to do motion access direct commands, and quickly go in here to this. So we can go to motion direct commands, and we can turn the servo on, okay, and it's locally disabled. So let's go in here. I want to show you one very important thing that I did forget. So see, this box right here is called drive enable input checking. If you have this box checked, that means you need to have wiring into this. You need to have wiring into your controller for the actual drive enable. Now currently I do not have that. I do not have that wired up. So I'm going to uncheck this box, hit apply, and then come over here. Now then I'm going to come back in here to motion access direct commands, and then I'm going to turn my servo on. My servo did cut on. I cannot move it anymore. Okay, so keep in mind, if I do cut it off, I have the ability to move the servo with my hand. You see that? Now if I turn it on, it's naturally controlling itself. I can no longer control it, or I can no longer turn it with my hand. Then if we come down here to a jog, I can jog it at a simple speed of 1, and you can see that the motor does actually run. Now that's a forward command. If I do choose to do a reverse command, you'll see I can reverse it just like that. I'm running it at a really reduced speed so that it, you can kind of see the function behind that. And if I want to stop it, I can issue a stop all command right here. Now this, and then make sure you turn it off. So this is the base principles of how to set up a servo, how to get it working, and then what we're going to do is we're going to come back on the very next couple videos, and we're going to actually show you again, with this video, this is basically the foundation, the fundamentals, the things you need to know about setting the servo up, and timing, and then making sure that the PLC processors actually timing everything the correct way. It does have time synchronization on, as we talked about, very important factor. And another thing is setting up your servo, setting up your motion group, setting up your motion group timing, and then what we're going to do from here on out is we're going to build this program and kind of build off of it to show you some simple ladder logic code that you can do to actually control this. So hopefully you learned a lot out of that video, and I appreciate you guys, and we'll see you guys on the next one.